on this channel. Today we will learn permutation and combination. The first thing comes in your mind when I told you permutation combination, that the formula NCR or NPR. We can write it as NCR or NPR. But forget about it. We will start with the approach how to solve question and how to understand the question. Okay, so we will start with the word math. It has 4 letters: MATH. If I ask you how we can choose one letter from these word letters, the answer will be we can choose M, we can choose A, we can choose T, we can choose H. There are 4 ways of choosing one letter. Okay. Now if I ask you how can we choose 2 letters from this word, so we can choose either MA or MT or MH or AT, AH, and we can choose TH. There are 1, 2, 3, 4, 5, 6 group of letters are possible. So if we want to solve it quickly, we can use the formula of combination called NCR. We have 4 letters, means n is equal to 4, and we are choosing 2 letters, r is equal to 2. Then 4C2 is equal to factorial 4 upon factorial 2 factorial 4 minus 2. So 24 divided by 4. It means we have 6 ways. So these are the ways of choosing one letter or 2 letters from the given letters. Now if I ask you how can we arrange these letters, if I ask you choose 2 letters from the word math, then we write or we have already written that there are 6 possible ways: M, A, M, T, M, H, A, T, A, H, T, H. And how can we arrange them? We can arrange them in a reverse order like AM, TM, HM, TA, HA, HT. So there are 12 arrangement possible. Whenever we have 2 elements, we can arrange them in AB and reverse order BA. So we have 2 arrangements. So similarly, when we have n element, we can arrange them in factorial n. Okay, so we have n element, we can arrange them factorial n. So before arranging them, we are choosing these letters. So first of all, we have 4 letters, we are choosing 2 letters and arranging 2 letters each. So the answer will be factorial 4 upon 2 into 2 into 2. So the answer will be 12. So now you can understand that how can we choose and how can we arrange the given letters. So now if I ask you how can we arrange the all letters present in the word math. There are 4 letters present in this word. So we can arrange them in factorial 4 ways. It means we have 24 arrangement. Now going to the next question, if we have the word apple, how can we arrange all the letters? So we can see that there are 2 similar letters present in this word. So if I write this in this way, P1 and P2, so we can arrange it like this, A, P1, P2, LE. We have 5 places to fill. Now arranging them in different order, P2, P1, L, E. Writing some more examples, L, A, P2, P1, E. Writing some more, L, A, P1, P2, E. And so on we can write all the arrangement possible. So we can see that there are 2 very similar arrangement. Means if there are 5 letters in this question, so we can arrange them in factorial 5. But if P1 is equal to P2 is equal to P, the arrangement will be half. So we can divide it by 2. So the final answer will be factorial 5 upon 2, or we can also write it factorial 5 upon factorial 2. Now going to the next example, if we have the word AIEEE, All India Engineering Entrance Exam, so we can see that there are triplet of E. E is present in this question 3 times. So what are the total arrangement of these letters? So as we can see, there are 5 letters and repeated letter is 3. So we can arrange it in this manner, factorial 5 upon factorial 3. So the correct answer will be 120 upon 6, 20 arrangement possible. So whenever there are same letters present in the word, the total arrangement reduced by divide by the number of repetition. Going to the next word, if we take general case of total letters N, P same kind of letter, Q same kind of letter, and R number of same kind of letter, so we can write the total arrangement possible will be factorial N upon factorial P, factorial Q, and factorial R. So in this way we have found that the correct answer of this question. Going to the next question, if I ask you the 4 letter or 4 digit password in your phone, you can how many ways you can fill 4 letters or 4 digits in your password. So we have 4 places and we can fill it with the number 0, 1, 2, 3 up to 9. So we can fill this place by 10 ways. We can also fill this place by 10 in 10 ways. Similarly here 10 and here 10. So the total numbers of arrangement will be 10 to power 4. Okay, so here is the question. If I ask you how many password can be made using the pattern, what will be the answer? This is the question for you. Now going to the next question, we will study about the circular arrangement. First of all, we have studied the linear arrangement in which we filled letter or word or number in linear fashion. In circular arrangement, we fill in a circular manner. So for linear, if n places are available, the answer will be factorial n. But for the circular, if n elements are present, then the answer will be factorial n minus 1. Why is this happening? We will see in the next page. Because in linear method we have ranking or order. This is first, this is second, this is third, and this is fourth. But in circular manner we don't have absolute position of these element. We only know this location relative to its neighbor. So if I ask you the location of one, it depends on their neighbors B and C. So due to this problem, we have reduced arrangement factorial n minus 1. Now if we will finding the arrangement, if we will find the arrangement in a garland, find arrangement in garland or in beads. So the or ring. So the ring is same as clockwise or anti-clockwise. So there is no difference in the clockwise and anti-clockwise sense. So the total arrangement are reduced by half. This will be the correct answer. Now, now if you are arranging a party and if you are inviting some guests, so we can say that there are n relatives you have and you are inviting are members. So what will be the choosing method? NCR. And if you are asking them to arrange on some particular seats, the arrangement will be NPR. But what will happen if you have M members, M VIP members? In this case, now taking an example, if you have 10 relatives and you are inviting 7 members of them and 3 are VIPs, so the total arrangement, so the VIPs are must be included. So you don't have to choose the 3 VIPs from the 10 relatives. So the effective choices you have are only 7. 10 minus 3 is equal to 7. 7C, and you are 7 minus 3 is equal to 7C, 4. You are inviting only 4 members from 7 available members, and from 3 VIPs you are inviting all 3 VIPs. So it will be 7C4 means factorial 7 upon factorial 4 into factorial 3 into 1. And if you are arranging them, the possible ways will be factorial 7 upon factorial 4 factorial 3 into factorial 7, because there are 7 members you are inviting. So this will be the final answer. Now taking an example in which you don't want to invite k members or 2 members. So you have 8 members available and you are inviting 7 of them. Okay, and from the 2 members you are inviting none of them. Okay, so the answer will be 8C7 means factorial 8 upon factorial 7 into factorial 1. And if you are arranging them, so the answer will be factorial 8 upon factorial 7 into factorial 1 into factorial 7, because there are factorial 7 members are available in the party. So the correct answer will be factorial 8 arrangement. Now going to the next question. You are taking an exam, and in that exam you have to at least pass in one subject. You have to at least pass in one subject. So you can pass all 5 subjects, or you can pass 4 subjects out of them, or you can pass 3 out of them, 2 out of them, and at least 1 out of them. These are the possible choices you have. Now if I add an extra term 5C0 and subtracting the term 5C0, the sum of these numbers will be 2 to power n, and subtracting minus 5C0 will be 2 to power n minus 1. So you can pass that year in 2 to power n minus 1 ways. So if you have similar t-shirts like Mark Zuckerberg, and you are choosing one of them, if you have 5 shirts of the same color, they are all identical. So how many ways you can choose? One of them is only one way, because all are identical. There is no difference which one are you taking. So there is only one way.